Let's have a look at proposition 1, which is a classic construction. Now, what we're going to do is, on a given finite straight line, to construct an equilateral triangle. So that's what we're trying to do. And let's think about what we're given. Let AB be the given finite straight line. So this is what we're given. Simply the line segment A over to B. Let's first produce the construction. With center A and a distance of AB, let the circle BCD be described, which we can do by the third postulate, because we have a center and a distance. So on AB, using AB as the radius. And remember, we're using ruler and compass construction, so we would produce this with a compass. Now, in terms of the labeling, we're going to let C be the eventual intersection point between two circles. And D, we just place as an additional label over here to designate the left-hand circle. Next, what we do is, with a center of B, now taking B to be the center of a circle, and the distance of BA, so we're going to use this as the radius, we're going to let the circle ACE be described, again through the third postulate. So B is the center, BA is the radius. We produce that with our compass. Let's designate this point up here by C, and we'll designate the circle on the right by E. Next, what we do to complete this construction, from the point C, in which the circles cut one another, to the points A and B, let the straight lines CA and CE be joined. So what we do is we simply produce a straight line from C over to A, and C over to B, which we can do through the first postulate, since we can join 2 points with a straight line. And thus we have the construction. Now what we have to do is prove that this triangle that we see is in fact an equilateral triangle. How do we prove this? Well, let's think about these two circles a little bit further. Now, since the point A is the center of the circle CDB, so let's think about this left-hand circle here. A is the center. AC is equal to AB. Why is that true? Well, from definition 15 and also definition 16, these straight lines which come from the center, namely A to C and A to B, are equal. Or to put it another way, they're both radii of the same circle, so they must be equal to each other. And then we think about the circle on the right, CAE. Again, we have our center B, B to C, and B to A are both straight lines coming from the same center. Therefore, these two are equal to each other. CB is equal to BA, as we see over here. And CA is also proved equal to AB. We just showed that A over to C is the same thing as A to B. CA is just taking these in reverse order. Therefore, each of the straight lines, C to A and C to B, is equal to AB. C to A is equal to AB, and so is C to B. That's also equal to AB. But things which are equal to the same thing are also equal to one another. So AB is being used to mediate the equality that we're trying to show between A and C, or C and C and B. Therefore, all three of those lines are equal to each other. And since they're equal to each other, we have the equilateral triangle that we propose to construct. Now that we've been through one of these propositions, let's have a look at the structure and see what Euclid's doing here. So we have the title first, obviously. So what does he first do? He tells us what we're given. We're given the finite straight line AB. Then he tells us what it is that we're trying to construct or prove. In this case, we're trying to construct the equilateral triangle upon the straight line AB. That's what we're trying to do. And then he tells us what the construction is. How do we do that? And we went through those steps. And then he proves that the thing that we constructed was actually an equilateral triangle. He gives the argument. And then he draws a conclusion and reminds us that that's what we're trying to do. This is the QED. So make sure you understand all the steps in the construction and in the proof. And this is a good construction/proof to memorize and just commit to your general knowledge.